This is a workflow just to demonstrate a few concepts about counting terms, measuring percentage of terms that are associated with positive and negative sentiment. This is what you've already seen with the typical pre-processing with the part of speech tagger, bag of word creator, punctuation eraser, etc., etc. And then instead of using all of these to develop our classifier, what if instead we went through and determined which of these terms occur frequently enough so that they're really a potential candidate for an input to predict a model. Obviously, if a term occurs once and only once, and it's in a positive document, while it's 100% associated with the positive document, it doesn't contain a lot of power or support to justify believing that it truly is associated with positive documents. So I created this meta node that's labeled unique terms. I'm going to go into here and show you what's going on inside here. The first step is to use the category to class node from the text mining options. And inside here, we're just creating the classes from the documents we already have available to us. And just so you can see, this is labeled positive and negative. The positive ones are at the top and the negative ones are at the bottom. And we see 44,914 terms that we have in these documents. These records, as we've discussed already in other homework, these are on the document term level. So every document, we see these documents, you can see the same text. I'm going to scroll up a little bit just so you can see how many terms are associated with that document. And then we've got another document, and we look at each of these terms individually within the document. Okay, so once we do that, I'm going to convert the categories to numbers with the category to number node. It's going to start with 0 and increment by 1. It's only going to be 2 categories, so it's fairly straightforward. And all that does is create an additional column where these categories are labeled 0 and 1. 0 for positive documents and 1 for negative documents. I guess if I was doing this again, maybe I'd make 1 positive and 0 negative, but it really doesn't matter for our purposes here. So then my next question is, how many times does a term occur? And this is, as I said in the notes already in the PowerPoint, where we can use a group by approach. And the group by approach just says, let's group by term. So we've got our 44,000 term document features. If we group by terms and count how many times the term occurs, how many documents the term occurs in, here, that will tell us the number of times that term appears in our data. And then I'm going to do something additional to that, and that's look at the document to class, that number, the 0, 1 number related to positive and negative reviews. I'm going to sum them up. So this is summing up the negative reviews because I have negative reviews targeted, labeled as 1, and the positive reviews as 0. I didn't change anything, so it's not going to complain. And that's why I'm renaming these columns. So we've got what I'm calling total hits, which is the number of times the term appears in the documents, and num negative, which is the number of times that's negative. And num negative is just the count, or the sum actually, of how many times that occurs. That one label associated with negative reviews occurs in our data. So now that we know we've got all these terms that we've defined, and just to refresh our memory, we've got 17,697 individual terms, unique terms in this data, which is the number of rows after we do the group by. So now if we wanted to find out how many times terms occur, how many do we have that occurred only once, how many twice, how many 3 times, I'm just going to copy and paste this group by. And we're going to group by, instead of the term, now we can group by the count. So I'm removing term from this group by. I'm going to group by the counts. And this time I'm going to count the terms. So bring terms over here, and I'm going to select count. So now just to remind ourselves what we're doing, now that we've got the number of rows in this data are the number of terms that we have available to us. And we've got the count of those. So if I do a group by counts, I'll have a count of how many times each of those counts occurs. How many terms do we have that occur once or twice or 3 times? And let me run this quickly and see what we get. Here's our group by table, and we can see from this when I count documents. So we have 11,425 terms that occur only once in the data. So of the 17,000 terms that we have available to us, 11,000 occur only once. So in terms of data reduction, this is an excellent candidate, obviously, of terms to get rid of, because if they occur once, they're not going to help for classification, and they're really not going to help for any kind of even document clustering, unless, and this is the one caveat, unless these terms can be grouped in some way with other terms. So if they're a similar term, a synonym, that kind of thing, we want to do all that function first, do all the grouping we want to do, whether it's removing part of speech or finding synonyms. We do that first before we do this variable selection. But for right now, I just want to look at it this way and look at the variable selection capabilities we can do. So here we have the, if we want to keep just terms that occur 10 or more times, we'd get rid of all of these. We'd get rid of, 13, 14, 15, like 16, over 16,000 terms. In fact, I can tell you exactly how many there'll be, because this row filter at the end is excluding rows that occur 0 to 10 times for our total hits. And nothing changed. So I'll just look at our filtered results. And there's 643. So we begin with 17,000, and we end up with 643 terms that occur in some proportion of the documents. So that's one level of variable selection we can do. A second thing we can do is look at which terms actually have some discriminatory power. And we're seeing the summaries here. I'll show you how we can compute it in just a moment. But here are our same counts that we saw before. And film, as you might expect, occurs lots of times. In fact, that's the most frequently occurring word in our corpus. 176 documents it occurs in of the 202 we have in this particular data set. The word movie occurs in 148 of the 202 documents. So that's all well and good, but one thing I computed then was what's the percentage of documents that term is related to a positive review, what percentage of the time is related to a negative review. And you can see from these percentages, if you're only positive 51% of the time and negative 49% of the time, it's not very useful in discriminating positive from negative reviews, unless it's used in combination with other terms. But on its own, it's not going to be a useful discriminator. So if we wanted to do a second level of variable reduction, we could do so by looking at positive reviews. I'm going to sort by percent positive, and we could see some words, terms that are associated with positive reviews. Things like memorable and terrific, excellent, enjoy, and enjoyable. To related words, obviously, or enjoyed. If we did stemming, all three of these would fall into the same bucket, and that would be a strong argument for stemming in this particular corpus, this particular text mining problem. So you can see the relationships, the 90, the 80s, and the 70% positive reviews. Now notice that most of these occur relatively infrequently. However, if we did group together the enjoyeds and the variance of those, we would have 20 plus 13 plus 11. So we'd have 44. 44 of the 202 documents have enjoy or enjoyable or enjoyed in them. We don't know if those are unique, so it could be less than that. But those terms occur, in dozens of times with an 80+% relationship to positive reviews. And on the negative side, this term supposed is, interestingly enough, always negative 12 times. Mess is 93% negative. Worst is 92% negative. And then some other things like dull and poor. I don't know why girls is listed as negative. I do not believe that inherently should be a problem. We'd have to look at the data to see why that particular term is showing up with negative reviews, if it's related to some specific movies that somebody's referring to. But then there's others which are more obviously negative terms, like bad and ridiculous and boring, pointless, stupid, pathetic, waste, those kinds of terms are strongly related to negative reviews. So let's go back and look and see how we accomplish that. The sorter node doesn't matter for this. I'm going to look at the math formula first. So in the math formula node, we wanted to compute the percent positive reviews, and all it is the number of total hits, number total times a term occurs in our corpus, minus the number of times it was negative. So this sum, or this difference I should say, are the number of positive reviews, number of positive times a term is related to a positive review, divided by the total number of hits, number of times that term occurs in the corpus. And the negative reviews is likewise computed in that way, number of negative divided by the total. So very simple. So then we have this kind of result, a row filter, just to throw away the low support examples, but we could have a secondary filter to say something like this. Let me just copy and paste this, and I can show you what I mean by this. We could connect up. I'm going to get rid of this output port for a moment. Connect this up, and this time we're going to say include percent positive, say between 80 or let's say 75 and 100%. And this would only contain words with high positive percentages. And there are only 24 of them that occur that often. So we could do that kind of filtering. The other way we could do this here, we could create a math formula and create a 1-0 flag with some more, with some fancier logic to select out the variables. And there's a third way we could do this in KNIME. We could do a rule. We can create a rule with the rule set editor, but we'll use the it's the rule engine, and we could create a rule that identifies positive or negative reviews by doing something along these lines. So if the percent positive is greater than or equal to 75.0, then we'll do keep, and if percent negative is greater than or equal to 75.0, we can say keep, and otherwise the default is remove. We can call this high association with pos negative, some variable name like that. So very simple rule engine, rules, and we can look at these results and we see which ones we'd remove, which ones we'd keep. Let's sort ascending, and these are all the ones we would keep with label keep, and they either have percent positive high or percent negative high. The rule engine's handy. We could do this with a math node. We could do this with filters. There's lots of ways you could do it, but the rule engine is handy because you can keep all these complex rules in a simple. I should have made this 75. You can keep all these in just a simple little interface here. We could also do something more sophisticated. We could say we'll keep all the high positives, all the high negatives, and we'll only keep the middle ones if their support is high enough. So we won't keep any occurrences of 10 reviews that with either a positive or negative label if it's a 50-50 split. So if there are 5 positive, 5 negative, there's no point in keeping that one. But maybe if there are 80 occurrences, there still may be a way to interact with that variable with something that's more positive and negative to get a better result. So there's lots of ways you can accomplish this idea of reducing the number of keywords, number of in the bag of words, so that we don't have the problem with huge tail distribution. Hope that helps understand a little bit more about the process we want to go through with the number of unique terms. Just from this very simple process, I'm going to bring this back over. We've already reduced down to 643 terms, and if we wanted to reduce that down further to looks like a matter of a few hundred, we could get down, or less than 100, we could reduce it down by just selecting very highly positive or negative keywords.